Okay, hi again everyone. Here we are in section 3.5 of our statistics class notes. We're on page, oh shoot, I forgot what page. We are on page 43. All right, so I just got done talking about on page 42, we learned how to find a 5-number summary for a data set, and we also talked about what a box plot looks like and how a box plot is a quick way to get that 5-number summary or visually. All right. One thing I did mention in the last video also is that you should look for outliers beyond those fences. So any dots that appear up beyond the fence to the right on your box plot would be an outlier up towards the right side of your data set, and any dots that appear to the left of the fences on the left side of the box plot would also be considered possible outliers. So the rule that we use for finding those outliers is sometimes called the 1.5 IQR rule. That's kind of what I call it. But that tells us basically that's a way for me to remember where the fences are. So the lower fence is 1.5 times IQR below Q1, or the first quartile. So the formula for that is Q1 minus 1.5 times IQR. And remember that IQR is Q3 minus Q1. So this is exactly the formula right here. This is an example of a calculation we would want you to be able to compute on the exam. Very simple calculation, just subtracting and multiplying. The upper fence is 1.5 times IQR, or 1.5 times the length of IQR above Q3. So the formula is Q3 plus 1.5 times IQR. Or remember again, IQR is Q3 minus Q1, so this is the formula without writing the word IQR in there. So values more extreme than these fences, which is what I was just trying to talk about, are outliers. In other words, values less than the lower fence or greater than the upper fence. So for example 48, the first and third quartiles in the distribution of daily high temperatures in San Francisco are given to us at 59 degrees and 70 degrees Fahrenheit respectively. So Q1 is 59, Q3 is 70. So that's what we're given. Using these values, what temperatures would be considered outliers in San Francisco? So we first have to construct the fences. So the lower fence is Q1 minus 1.5 times IQR. IQR is Q3 minus Q1. So you just plug that in your calculator, making sure order of operations are done correctly, or if you have a TI 83 or 84, you just plug it in just like this, and you get 42.5. Upper fence is 70, or Q3, sorry, plus 1.5 times IQR. In other words, 1.5 times the length of IQR above 70. That comes out to be 86.5. So in other words, we would then agree by the 1.5 IQR rule that any temperature below the lower fence, which is 42.5 degrees, or above the upper fence, which is 86.5 degrees, would be considered to be an outlier. As another example, let's use StatCrunch to find the 5-number summary for a sample data, and then use the 5-number summary to determine if the data set contains any outliers. Okay, so here actually is the 5-number summary. Let me go ahead and go to StatCrunch and show you how I computed that. It's all right here, so you can see it. We're going to look at the ages in this data set, but I'll show you the data set in just a second. So the data set is this NFL players from 2016. So this is a data set that lists all the players that played in the National Football League in 2016. This column here labeled age is their ages, and that's the data. That's the one variable that I want to work with in this example. So the first thing I'm going to do is I'm going to go to Stat, Summary Stats, and I want to look at the column where age is, so it's columns. I'm going to pick age. Okay, now I want the 5 numbers that I need for my 5-number summary. So I'm going to scroll down the different stats that I want. They're not there yet. Whoops. I want let me use this instead of going too fast. Don't want all of those. I want the median. Okay. And then I want the minimum. So I'm going to use the control button when I'm using a PC so I don't get the range. I just want the 5 numbers. So minimum. I want the maximum. And I want Q1 and I want Q3. Okay, and that's all I want to spit out right now. So I'm going to hit compute. And there they are, the 5-number summary. They're not in the correct order because it should be minimum, then Q1, then median, then Q3, and then maximum. This doesn't tell me if I have any outliers. I need to figure that out first. But that's how I can quickly get the 5-number summaries from a very large data set. All right, so let's go back to our notes. And there they were, the numbers we just found, 20, 23, 25, 27, and 43. Sorry, I had this signature here. I was actually working on another data set, and I decided to change it to age and forgot to change this when I printed it out. Okay, so first thing I need to do is I need to find the lower fence and the upper fence to see if there's any outliers. So first of all, find IQR, which is Q3 minus Q1. Very easy here. 27 minus 23 is 4. Then 1.5 times IQR, 1.5 times 4 is 6. So the upper fence is Q3 plus 1.5 times IQR, so 27 is the upper fence. I'm sorry, is Q3 plus 1.5 IQR is 6. So the upper fence is 33. So any age higher than 33 will be considered an outlier. The lower fence, Q1 minus 1.5 IQR, so 23 is Q1 minus 1.5 times IQR, which we figured out to be 6, is 17. So any age lower than 17 would be considered an outlier. I doubt there's anybody less than 17 years old in the NFL. Pretty sure there's outliers to the right, though. So, okay, so I actually could do a box plot, which I didn't do when I did this example, or I could just sort all the data and see where the outliers are. Okay, so we could do that. You know, 30. I could sort the data, select all columns, then sort by the column age, choose to replace the current columns or open in a new data table, and then select compute. Okay, so I'm going to go back to the data set. Okay, get rid of this for a second. So I'm going to go to data, and I'm going to go to sort. Okay, I want to sort all columns at once. Okay, so I'm going to sort. And I'm going to sort by age. So it's going to sort by the age. But when I sort all columns at once, that means that everything stays together. I don't mix up my data, which of course is what I want to do. And I'm just going to replace my current columns rather than open up in a new data set. So I'm going to hit, now let's open up in a new data table so I can save this and not worry about messing this one up. So I'll hit compute. And it's sorted by age. So I got the lowest ages. Notice there's nobody less than 17 years old. Okay. So when I go back here, now I'm looking to see if there's anybody older than 33. There's a large data set, right? Anybody older than 33? I'm still dragging down. I'm still dragging down. I'm still dragging down. Nobody older than 33 yet. Oh, there's a bunch. So 33 is right there. But I do have some people that are 34. I have some people that are 35, some that are 36, 37, 38, 39, 41, and 43. And then these were people that didn't have their ages, so we don't know about them. Okay, now the other thing I want to do is say, okay, so I know all the different data points, right? 34, 35, 36, 37, 38, 39, 41, and 43 are outliers. Now let's actually look at a graph, a box plot. So I'm going to graph a box plot here. I want to graph age. Okay, I want to draw the boxes horizontally because that's why I've drawn it, and I'm going to use fences to identify the outliers. So it knows to compute the fences by the 1.5 IQR rule. So I'm going to hit compute, and now I can see the box plot where notice there are no outliers to the left of the lower fence, and there are 1, 2, 3, 4, 5, 6, 7, 8 outliers to the right. That was all the people that were age 34, 35, 36, 37, 38, 39, 41, and 43. Okay, so, and that's it. There's a chapter 3 quick review. I'll let you go through that and I'll read it real quick, but just make sure this is a quick check. It's not it's not a full thorough review of chapter 3, but you should actually review your notes very carefully when reviewing for chapter 3. So what are the measures most commonly used in symmetric and skewed distributions? So remember, for symmetric, we want to use the mean to represent the center or the typical value, and we want to use a standard deviation to represent the spread. For a skewed distribution, either left or right skewed, we want to use the median to represent the center and the IQR to represent the spread. If we do have a symmetric distribution, the mean and the median are approximately the same, and it doesn't matter that much which one is used, but by standard rule, we use the mean. In a skewed right distribution, the mean is greater than the median, and it's not a good representation of the center. It's pulled to the right, so we don't want to use that. We want to use the median. In a skewed left distribution, the mean is less than. It's pulled to the left. It's less than the median. So again, not a good representation of the center, so we want to use the median. And why do we use them? Because the median and IQR are most resistant to outliers. Okay. Now, one last question. If I gave you a 5-number summary, here it is. Based on this summary, this is temperatures in a certain city produced this following 5-number summary. So based on this 5-number summary, how would I know what temperature could be considered a potential outlier? You can't get it straight from the 5-number summary. You have to first compute the upper fence, which is not in our summary. So remember, the upper fence is Q3 plus 1.5 IQR. That comes out to be 91. So any temperature more than 91 degrees would be a potential outlier.